It's your friendly math tutor, Miss C here, to unlock the magic of converting general quadratic form to factored form and then to identify the roots. So here we go. We have equation y equals x squared plus 2x minus 8. This is in general form or standard form. We are going to be trying to get it into factored form, which looks like this. So what you're going to notice is we have an a here. A is the same in all quadratic forms. And so our A in this equation would be right here. When we don't see a number, we know that number is a secret one because in math, we don't write ones that are multiplied. So we just know. So let's go ahead and talk about how we convert this into factored form. So factored form is the result of factoring. So what we're trying to do is find two numbers that multiply to -8 and two numbers that add to 2. So we can look at that through as a factor pair. So we know that -8 can be made by -1 times 8 and 1 times -8. Okay. We also know that factors of 8 are 2 and -4, right? And -2 and 4. When we multiply those, each of those 4, we get -8. Now, here's what we need to think about. When we change these and we look at adding them, do we get +2? So I can say -1 plus 8 does not equal 2. 1 minus 8 does not equal 2. 2 minus 4 does not equal +2, but -2 plus 4 does. So this is our factor pair. So we're going to go ahead and just write this. We know that A is 1, and in math, we just let that one be hidden. So we're going to say x minus 2, right? Because that's this factor, and x plus 4. And this is our factored form. Now, if we were to redistribute this, we would find that we would get exactly the equation that we started with because these are equivalent forms. They just give us information. So the particular information that factored forms gives us is the roots. So you might have heard roots called a few different things. They can be called roots. They can be called zeros. They can be called x-intercepts. There's slight differences between all of them, but for the most part, they're all the same. And they happen when y equals 0. So to solve for this, I'm going to say 0 equals the quantity of x minus 2 times the quantity of x plus 4. Now, here's what I know about binomials. When this whole binomial is equal to 0, the whole equation is equal to 0. And when this binomial has a value of 0, the whole equation also equals 0. So we can think of it as solving for something like this. Anytime either one of these equations is true, we have a root. So in this case, one of our roots is +2. So I'm just adding 2 to both sides. And in this case, x is -4, subtracting 4 from both sides. The shortcut way of doing that is to say, what does x have to be to make this 0? Oh, it needs to be 2, okay? And then what happens for x to be, or what does x need to be in the second binomial to make 0? Oh, it needs to be -4. Shortcut way of doing it. Because these can be considered x-intercepts, we can also write them as coordinate pairs, such as 2, 0 and -4, 0. If I were to graph this, I know that my graph would look something like this. Okay, so I have a point at +2, that's my x-intercept, and I know I have one at -4. So my graph is gonna look something like this. Definitely not very accurate, but it's an upward facing parabola with the graph passing through the x-axis at -4 and 2. Thank you for converting from general form to factored form with me and identifying the roots.